What if the world we trust most is only the shape our minds give to mystery? For most of human history, people looked up at the night sky and saw permanence. The stars returned, the seasons turned, stone felt solid beneath the hand, and time seemed to move in one direction only, like a river that never questioned its banks. Reality appeared dependable, almost intimate. We built homes inside it. We buried our dead within it. We gave names to its patterns and called that knowledge. But every age eventually reaches a threshold where certainty begins to thin. A strange thing has happened in modern thought. The deeper science has looked into matter, space, and consciousness, the less the universe resembles the simple physical stage we once imagined. At the smallest scales, reality flickers with uncertainty. At the largest, it bends around invisible rules we do not fully understand. Mathematics describes the cosmos with an eerie precision, as if nature were speaking in a language older than stars. And in that precision, some thinkers have begun to ask a question that sounds less like physics than philosophy, less like philosophy than a whisper in the dark. What if the world is not what it seems at all? This is not a journey into paranoia or spectacle. It is something quieter than that, a walk along the edge of human understanding, a record of ideas that emerge when reason follows its own trail to unsettling places. Some of these theories are elegant, some are deeply strange. None of them can be held like a stone in the hand. Yet each one reflects a timeless human impulse, to look beyond the surface of things and wonder whether the surface was ever the truth. Perhaps reality is a structure. Perhaps it is a projection. Perhaps it is an interface shaped by survival, not truth. Or perhaps the oldest mystery remains the deepest one, not whether the universe is real, but what we mean when we call anything real at all. What if the equations came first, and everything we love arrived later? Imagine a chalkboard in an empty room. No planets, no oceans, no living eyes to read the symbols. Only patterns, relationships, pure structure. It sounds lifeless at first, but some physicists and philosophers have asked whether this abstract realm may be more fundamental than matter itself. Not a tool for describing reality, but the hidden substance of reality. This idea is often called the mathematical universe. Its central claim is both simple and difficult to accept. The cosmos does not merely obey mathematics. It is mathematics. The orbit of a planet, the charge of an electron, the firing of neurons behind a memory. Each would be part of one immense structure, coherent in the way a theorem is coherent. We would not be creatures standing inside a physical world that happens to follow equations. We would be expressions of those equations, living from the inside of a pattern too large to see. There is something haunting in that possibility. A mathematical object does not need brick, blood, or starlight in order to exist. It does not wait for permission from time. It simply holds together in perfect relation to itself. If that is true, then our universe may be only one valid structure among countless others, each internally consistent, each as real as this one to the beings within it. And here the idea becomes strangely intimate. Love, grief, music, memory, things we experience as warm and immediate, would not be less meaningful in such a universe, but they would be stranger. Consciousness itself might be what a deep pattern feels like from the inside. We often imagine mathematics as cold. Yet perhaps that is because we have mistaken abstraction for distance. What if numbers are not far from life, but the quiet architecture beneath it? And if reality is built from pure relation, what then becomes of the self that calls itself real? What if your life depends on a system so vast and hidden that you could never reach its edge? Picture a city at dusk, windows glow, conversations drift through apartment walls. Somewhere a child is laughing. Somewhere else a man sits alone with a grief he cannot name. From the inside, every moment feels immediate and self-contained. Yet the simulation argument asks us to imagine something deeply disorienting. That all of it, streets, weather, memory, desire, might be generated within a reality built by other minds. The modern version of this thought is not really about science fiction. It begins with probability. If a civilization becomes advanced enough to create detailed simulations containing conscious beings, and if it runs such simulations in large numbers, then simulated minds would eventually outnumber original biological ones. In that case, any ordinary observer who wonders about their place in existence should, statistically, suspect they are more likely inside one of the copies than in the first world that made them. The force of the idea lies in how little spectacle it requires. No glitch in the sky, no visible code behind the trees. A convincing simulation would feel exactly like life, because, for those inside it, feeling is the reality that matters. Hunger would still hurt, tenderness would still soften a voice, loss would still leave its familiar silence in a room. And yet there is a colder layer beneath the thought. If our existence depends on an external system, then continuity itself becomes a kind of borrowed grace. The world could be paused, altered, or ended for reasons beyond our understanding. The future would not only be uncertain in the human sense, it would be contingent in a deeper way, held open by powers we cannot perceive. Perhaps that is why this argument lingers in the mind. It does not merely ask whether the world is artificial. It asks whether reality has ever belonged to us at all. And if our lives are, in some unimaginable sense, hosted elsewhere, would that make our joys less real or only more fragile? What if depth itself is a kind of illusion and the world unfolds like an image cast from a distant edge? Stand at the ocean sometime just before dawn. The horizon appears to hold the world together. Sea below, sky above, and between them the faint suggestion that space has volume, that distance is real, that the far line where light gathers is only another place waiting to be reached. We trust this sense of depth instinctively. It is how the body moves through life. Yet modern physics has opened the door to a more unsettling possibility, that the three-dimensional world may be a projection of information written on a boundary we cannot see. This is the spirit of the holographic principle. It grew from black holes, those strange regions where gravity becomes so intense that even light cannot escape. When physicists tried to understand how black holes store information, they found something unexpected. The amount of information seemed to scale not with volume, but with surface area. It was as if the contents of a region were somehow encoded on its edge, the way a flat plate can contain the instructions for a hologram that appears to have depth. If that logic extends beyond black holes, then our universe may be far stranger than intuition allows. Everything we call space, mountains, skin, breath, memory, the distance between one star and another, could arise from information laid out on a more fundamental surface. We would still live, move, age, and love within what feels like a deep and spacious world. But depth itself might be a consequence, not a beginning. There is something almost poetic in this. The universe, so full of texture and reach, may be more like music than stone, an experience emerging from structure, a dimension blooming from arrangement. What feels solid may be the visible face of something flatter and more abstract beyond us. And perhaps that is the deeper unease. We assume reality must resemble the way it appears. But what if appearance is only the final translation? If the world is a projection, then how much of what we call presence is simply interpretation shaped by limits we have never escaped? What if your memories arrived before the world did? It is one of the strangest ideas modern physics has ever taken seriously. Imagine a mind appearing out of chaos for only an instant, a fully formed consciousness suspended in emptiness, carrying memories of childhood rooms, old conversations, familiar streets after rain. To that mind, everything would feel continuous. It would believe it had lived a life. It would believe the past had happened. And yet the past, in this scenario, would be nothing more than a pattern assembled in a single moment. This is the troubling heart of the Boltzmann brain problem. It emerges from statistical reasoning about entropy, disorder, and time. In an unimaginably large or ancient cosmos, random fluctuations should eventually produce all kinds of unlikely arrangements. But here is the unsettling part. It is far easier for chance to assemble one isolated brain with false memories than to generate an entire long-lived universe with galaxies, history, and coherent biological evolution. By sheer probability, a lonely mind could be more common than a real civilization. The idea sounds absurd at first because it violates our deepest intuitions. We trust continuity. We trust that memory points backward toward actual events. We trust that the world existed before we opened our eyes this morning. Yet physics has repeatedly shown that the universe is under no obligation to honor human comfort. If a theory predicts that brief, accidental minds should vastly outnumber ordinary observers, then the theory creates a profound problem. It suggests that our own confidence in reality may not be as secure as it feels. What makes this idea linger is not only its strangeness, but its emotional precision. So much of human life rests on inherited continuity. Family stories, shared places, grief that stretches across years, love that deepens because it endures. The Boltzmann brain asks whether continuity is something we know or merely something we experience. And if experience can arrive fully formed, carrying a past that never was, then what exactly anchors a life to truth? What if the universe does not flow at all, but updates? Think of rain striking a window at night. From inside the room, the motion looks smooth, almost continuous. But look closer, and the illusion breaks into droplets, separate impacts, tiny events arriving one after another so quickly that the mind blends them into a single movement. Some physicists have wondered whether reality itself may work this way, not as an unbroken fabric, but as a vast sequence of discrete steps. This is the intuition behind digital physics and the cellular automaton view of the cosmos. In such a picture, the universe is built from simple rules operating on fundamental units, much the way intricate patterns can emerge from a grid obeying basic instructions. Complexity would not require a complicated foundation. It would arise from repetition, interaction, and time. Stars, storms, cells, language, memory, even consciousness could be the visible richness produced by an underlying logic that is astonishingly spare. The idea gains its power from certain features of modern physics. Nature seems to come with limits. There is a smallest meaningful scale for space, a smallest meaningful interval of time, a maximum speed at which information can travel. Energy appears in discrete quantities. At the quantum level, continuity begins to fray. To some thinkers, these are not random constraints. They look like signs of granularity, as though reality has resolution. If that is true, then what we call matter may be less fundamental than information. The world would not be built from solid substance in the old sense, but from states, transitions, and rules. Physical law would be what computation feels like from the inside. There is something both elegant and unsettling in that possibility. We are used to imagining ourselves as creatures moving through a material world, but a computational universe shifts the image. It suggests that existence may be processed before it is thing, pattern before object, update before motion. And if reality is written in steps too small to see, then perhaps what we call permanence is only the grace of an algorithm repeating fast enough to look like being. What if the oldest light in the universe is trying to tell us that space is not as impartial as it seems? Imagine unrolling an ancient map and finding not blank symmetry, but a faint tilt in the design, a slight preference, a direction that should not be there. This is close to what cosmologists encountered when they studied the cosmic microwave background, the dim afterglow of the early universe, a field of radiation so old it carries whispers from the cosmos when it was young, hot, and nearly featureless. According to the standard picture, that early universe should look statistically uniform on the largest scales. Not perfectly smooth, but without any grand orientation, as if chance had scattered its fluctuations evenly across the sky. Yet detailed measurements revealed a set of anomalies that refused to disappear completely. Large patterns seem to align in unexpected ways. One hemisphere looks subtly different from the other, and in one region there is a vast cold spot, like a silence stretched across billions of light years. No single irregularity proves anything extraordinary. Science is careful for good reason. Patterns can emerge from noise, and the human mind is gifted at seeing meaning where randomness may still rule. But the unease remains because these features all point in a similar direction. The universe may possess large-scale structure where simplicity was expected. For some researchers, these anomalies are unfinished data problems or unlikely statistical accidents. For others, they hint that the cosmos may carry deeper boundary conditions, hidden architecture, or constraints not yet captured by prevailing models. The thought is difficult to shake. If reality were somehow shaped, projected, or computed, then subtle asymmetries might be exactly the kind of trace we would expect to find, not in a laboratory, but in the background fabric of the sky itself. There is a special kind of humility in this moment. We are reading the faintest light imaginable, searching it for clues about everything. And perhaps the question is not whether the universe contains anomalies, but whether anomalies are how mystery announces itself when the ordinary story has grown too small. What if the universe is not merely possible, but improbably precise? Consider a lock with dozens of tumblers, each requiring an exact position before the door will open. Now imagine that every one of those tumblers must align not approximately, but with an accuracy so extreme that even the language of odds begins to fail. This is the feeling many physicists confront when they speak about fine-tuning, the uncanny precision of the constants that govern the universe. These constants are not poetic abstractions. They are the numerical settings woven into the structure of reality: the strength of gravity, the mass of elementary particles, the balance of forces inside atoms, the rate at which the cosmos expands. If some of them were even slightly different, stars would not burn as they do. Chemistry would lose its stability. Matter might never gather into planets, oceans, or bodies capable of asking questions. The universe would still exist in some form, perhaps, but not as a place where complexity lingers long enough to become life. That is what makes fine-tuning so arresting. The cosmos appears not simply ordered, but delicately poised. Many explanations have been offered. Perhaps countless universes exist, each with different settings, and we happen to live in one of the rare regions where life can emerge. Perhaps deeper laws will eventually show that these values could never have been otherwise. Or perhaps our intuition is misleading us, turning selection into design because we are the beneficiaries of the outcome. Yet the emotional force of the mystery remains. Fine-tuning presses on a very old human nerve, the sense that behind existence there may be choice, or necessity, or an architecture not yet visible. It asks whether reality is a fortunate accident, a lawful inevitability, or something shaped with extraordinary care. And maybe that is why the question feels larger than physics alone. To notice fine-tuning is to notice how narrow the ledge may be beneath our lives, how small a change it would take for music, memory, and mercy never to have entered the world at all. What if the world waits for us to look before deciding what it is? A beam of light passes through darkness. It reaches a barrier cut with two narrow openings, and beyond that barrier, a screen receives the result. The setup is simple enough to explain to a child, yet what it reveals has unsettled physics for more than a century. When no one measures which opening the particle passes through, the result resembles a wave interfering with itself, as though the light explored multiple possibilities at once. But when a measurement is made, the pattern changes. The wave-like ambiguity disappears. A definite path seems to emerge. This is the strange heart of quantum mechanics. At the smallest scales, the world does not behave like a collection of tiny billiard balls, moving through fixed space with predictable certainty. Instead, it appears suspended in possibility until interaction, measurement, or observation forces a single outcome into view. The mathematics predicts these outcomes with astonishing accuracy. What it does not give us, at least not unanimously, is a satisfying picture of what reality is doing before the moment of resolution. That gap has invited many interpretations. Some imagine branching worlds, others hidden variables, others still a more relational universe in which properties are not fixed until systems meet. But beneath the technical language lies a profoundly human disturbance, the suspicion that reality may not be complete in the way common sense demands. The world might not be fully settled behind the curtain. It may become specific only in the act of encounter. For those drawn to simulation-like models, this resembles a rendering strategy, detail appearing where attention falls, uncertainty preserved elsewhere. But even without that comparison, the deeper mystery remains. Why should observation matter at all? Why should knowledge, interaction, or measurement seem woven into the fabric of physical outcome? Perhaps the lesson is not that consciousness creates the universe, but that participation runs deeper than distance. We are not detached spectators standing outside the world, calmly recording it. We are part of the event, and if reality sharpens in relationship, then perhaps existence has always been less like machinery and more like conversation. What if the universe has a smallest grain, and one day we learn to see the seams? In the digital age, we are familiar with the illusion of continuity. A photograph looks smooth until it is enlarged. A film feels fluid until you remember it is made of frames. From a distance, the image persuades us. Up close, structure appears. Some physicists have asked whether space and time may hide a similar secret, whether reality itself is not infinitely smooth, but built from units so small that they form the deepest texture of the world. Modern physics already gives us a hint of this possibility. There appears to be a scale beneath which our ordinary ideas of distance and duration stop making sense. The Planck length and Planck time are not merely tiny measurements. They mark a threshold where current theories lose their familiar footing, as though the fabric of reality resists being divided forever. For some, this is simply the frontier of incomplete knowledge. For others, it suggests something more provocative, that the universe may have resolution. If space is discrete, then the old image of a seamless cosmos begins to shift. Movement would not be endlessly divisible. Time would not flow like water without interruption. Instead, the world might unfold in finite increments too small for any human sense to detect directly. A cosmos like this would resemble computation more than classical continuity, a lawful grid whose immense refinement gives rise to the appearance of smoothness. Researchers have even wondered whether such granularity could leave traces in high-energy phenomena, subtle directional effects, or boundary signatures that betray an underlying lattice. Nothing decisive has been found. But the very fact that such tests can be imagined changes the feeling of the question. This is no longer only metaphysical speculation. It edges toward observation. And that is where wonder meets unease. If reality has a hidden resolution, then perhaps our world is not an ocean without bottom, but a crafted surface of extraordinary depth. The question is whether discovering that structure would free us from illusion, or simply reveal that mystery, once magnified, becomes finer rather than smaller. What if space and time are not the foundation of reality, but the language our minds use to survive it? There is a quiet revolution happening at the meeting point of philosophy, cognitive science, and theoretical physics. It begins with a deeply unsettling possibility. Evolution may not have shaped us to perceive truth. It shaped us to stay alive. The colors we see, the distances we judge, the objects we name and trust may not reveal reality as it is. They may be more like symbols on a screen, useful, efficient, and profoundly misleading. Imagine the desktop of a computer. A folder icon appears simple, familiar, almost tangible in its own symbolic way. But no one believes the icon resembles the circuitry or magnetic states beneath it. It is an interface designed not to tell the truth about the machine, but to help a user act effectively within it. Some modern thinkers have suggested that perception may work much the same way. The world we experience, trees, bodies, horizons, motion, even the passage of time, could be an adaptive display, a translation shaped by survival rather than accuracy. What makes this idea more than metaphor is its strange convergence with physics. In some of the most advanced mathematical descriptions of particle interactions, the usual scaffolding of space and time seems to fall away. The calculations still work. In some cases, they become cleaner, more elegant, as though what is fundamental lies beneath location and duration rather than inside them. Space-time begins to look less like the stage of existence and more like a useful emergent picture. If that is true, then the human condition becomes both more fragile and more wondrous. We are creatures navigating an interface we did not design, relying on perceptions that may conceal as much as they reveal. The world feels solid because solidity is a meaningful signal, not necessarily because matter is what it seems. And perhaps the deepest mystery is this: if consciousness does not merely observe the world, but participates in constructing its visible form, then where does the interface end? And what kind of reality waits where our intuition can no longer follow? What if every attempt to uncover reality also reveals the limits of the one who is asking? By this point, the questions have begun to circle one another. Mathematics suggests that structure may be deeper than substance. Simulation arguments turn existence into probability. Quantum theory unsettles the boundary between possibility and event. Cosmology hints that the largest scales may carry signatures we do not yet know how to read. And the study of perception reminds us that whatever the world is, we never meet it unfiltered. We meet it through minds shaped by need, memory, and survival. Taken alone, each theory can be placed at a distance. It can be treated as an intellectual exercise, an elegant speculation, or a fringe possibility still waiting for firmer ground. But together they create a different atmosphere. They do not prove that reality is false. They do something subtler. They erode the old confidence that the world is simply what it appears to be. They suggest that human experience may be less like standing in open daylight and more like moving through a house of reflections, where every surface shows something true and incomplete at once. There is no shame in this uncertainty. In fact, it may be one of the most honest places science has ever brought us. For centuries, knowledge was imagined as conquest, as if the universe were a locked chamber that would someday yield its final mechanism to the patient hand. But these modern ideas tell a humbler story. They imply that observer and observed are intertwined, that the tools we use to measure the world are extensions of creatures who are themselves part of the mystery. That realization changes the emotional texture of the search. We are not outside the cosmos examining it from safety. We are expressions of it, asking questions from within its fabric, with instruments built from its matter and language shaped by its constraints. So perhaps the deeper revelation is not that reality is unreal, but that reality may be layered beyond the reach of any single frame. And if truth comes to us only in partial forms, then wisdom may begin not with certainty, but with the grace to remain astonished. What if the final boundary is not between the real and the unreal, but between what can be known and what must be lived? There is a moment in every long inquiry when facts stop feeling like answers and begin to feel like mirrors. The deeper we look, the more the universe reflects our oldest questions back to us. What is substance? What is mind? What does it mean to exist inside a world that can be measured with exquisite precision and still remain fundamentally strange? At that threshold, the search is no longer only scientific. It becomes personal. Because none of these theories, however abstract, stay in the realm of abstraction for long. They reach quietly into ordinary life, into the way we remember a parent's voice after they are gone, into the way a familiar room can feel both permanent and fragile, into the way time seems solid in youth, then porous in age, as if the years were not a road but a light changing over water. If reality is mathematical, simulated, projected, discrete, or filtered through perception, then human life does not become less meaningful. It becomes more delicate and perhaps more luminous. This may be the hidden thread connecting all these ideas. Not the claim that the world is fake, but the recognition that certainty has always been thinner than it appears. We have lived as though reality were a settled floor beneath us, when it may be closer to an unfolding relation, stable enough for love, grief, art, and memory, yet mysterious at every edge. The world holds, but it does not explain itself easily. And maybe that is why these questions endure. They allow us to speak in modern language about an ancient human feeling that beneath the visible order of things lies something immeasurably deeper, not necessarily hostile, not necessarily designed, simply greater than the maps we have drawn. So we keep asking, not because we expect the mystery to vanish, but because the act of asking is part of what makes us human. And perhaps the last wisdom is this: even in a reality we do not fully understand, kindness, wonder, and attention remain real forms of truth. In the end, the question was never only whether the universe is real. The deeper question was what kind of reality human beings are capable of seeing, and what remains beyond the reach of our senses, our equations, and our stories. We began with the confidence that the world was simply there, solid, external, waiting to be understood. But along the way, that certainty softened. Reality became less like a wall and more like a horizon, always visible, never fully reached. Some of the ideas we explored arise from physics, some from philosophy, some from the mathematics of probability or the biology of perception. Yet all of them converge on a single humbling insight. The world may be stranger than the language we inherited to describe it. Matter may rest on information. Space may emerge from deeper structure. Observation may participate in what becomes real. The mind may not reveal truth directly, but translate it into forms a human life can use. And still, after all the abstractions, we return to the ordinary things that anchor us. A hand held in silence, a photograph fading at the edges, the memory of a voice that still lives somewhere in the mind. These are not weakened by uncertainty. They are illuminated by it. If reality is more mysterious than we imagine, then each moment of connection becomes more precious, not less. Meaning does not depend on perfect metaphysical certainty. It grows in the space between ignorance and attention, between fleeting life and the desire to understand it. Perhaps that is the final lesson. We may never stand outside the system far enough to see the whole design, if design there is. We may never know whether the cosmos is equation, projection, interface, or something for which we have no name at all. But we are here inside the question, capable of wonder. And maybe that is enough. To be conscious for a little while in a universe that does not fully explain itself. To seek truth without turning mystery into fear. To accept that what is most real may not be what is easiest to measure, but what calls forth awe, humility, and care. So the story ends where every human search begins, under the vastness, looking up, asking what kind of world this is, and what kind of beings we become by trying to know it.